Okay, so next question. Check if two strings are anagrams. Write a function that checks if two strings are anagrams, which means they contain the same characters in a different order. Ignore spaces and case sensitivity. Okay, so the spaces and case sensitivity thing makes this a little bit more complex. So what I'll probably do is uh, remove all spaces and make everything lowercase, something like that, and then compare the resulting strings. So let's go ahead and write a function string. We'll call this remove spaces. Let's just do it in individual pieces. This will be a good example of trying to break problems down into tiny parts. In fact, we might even just say remove non-letters. All right, so removing non-letters. It's going to take in a string and return a string, which is the string we passed in with all of the things that are not letters, including spaces, removed from it. Okay. So we're basically going to be building a brand new string. So we'll create move this up some. So we'll say string answer is equal to the empty string. Then we're going to go through every character in S. So for int I is equal to 0, I is less than S dot length, I plus plus. All right. So now what we want to do is we want to keep things that are letters. Um, let's see, what would be the best way to do that? Let's go ahead and write another function that returns a Boolean, maybe called isLetter, that takes a char as a parameter, and it returns true if it's a letter and false otherwise, right? So we're going to go ahead and create our string. We'll call this map. And we actually could combine the letter and the lowercase part of this into one, but let's just do it as individuals so you get practice breaking things up into little problems. Okay, so I'm going to do all the uppercase letters. So I'm doing a string containing all the lowercase letters and all the uppercase letters. Okay, so did I get the whole alphabet? All right. And we're taking in a character C. So what we want to do is we want to search for C somewhere in that string. So we'll say for int I is equal to 0, I is less than map.length, I plus plus. So we'll spin through every character in map. We'll ask the question if map at bucket I, if the current character we're looking at is equivalent to C, that is, if we found this character living somewhere in this string, then we want to return true. If we've checked all of those things, we're going to return false. Now, as I kind of go through this, where this is a good question is it forces you to break things down into little tiny pieces. And even though you're going to feel like there's some redundancy in what we're doing here, consider that having a function called isLetter that allows you to decide if something a letter could be handy sometime in the future too. So having functions that kind of do like one thing, a specialized thing, can be handy And it's also going to allow you to kind of force you to break the problem down to small pieces. All right, so let's go ahead and go back to our other function, remove non-letters. So this guy's going to go through the string that was passed in, and we're going to ask the question, if s dot, or if s at bucket I is, we want to pass that to our is letter. So if is letter, s at bucket I, so if the current character we're looking at is a letter, we want to keep it. And we're going to keep it by just tacking it on to our string. All right, so when this function is done, what we're going to be left with is s with anything that is a space. And well, we're going to be left with s containing only letters. Anything that was a space, punctuation, anything that is a non-letter, just remove from it by building up the string containing only the letters that were in it. All right, so that's another feature now. Okay, so now let's go ahead and let's write a function called bool is uppercase. We'll have this guy take it a char C. You could do is lowercase as well, but effectively what I want to do is I want to go through and determine if it's an uppercase letter, I want to go ahead and convert it to a lowercase letter. And we've actually done that in another question. So this is kind of pulling a lot of the pieces together. All right, so is uppercase. We'll go write that down here. And I'm going to steal map here. And we'll slightly modify it, containing only the uppercase letters. All right, and then we'll have our for loop, where I is equal to 0, I is less than map dot length, I plus plus, and we'll ask the question, if map at bucket I is equal to the character that was passed in, that means that this character was found somewhere in this string containing only capital letters. And since this function's job is to determine if whatever character I passed it is uppercase, if I found it in there, I'm going to return true. After the for loop, if I am still alive, which means I never actually found it in there, which means I never return true in here, which means this function is not ended yet, I'll go ahead and return false. That's that means it was not an uppercase letter. Okay. All right. So now we have the ability to remove anything that's not a letter. We have the ability to go and find out whether something is uppercase. Now we want to convert uppercase to lowercase. Call this guy upper to lower, which I think was another one of the functions earlier in the assignment. Okay. And I'm gonna steal that string. And we're gonna call that guy uppers. And then I'm gonna steal the lowercase string as well. Call this guy lowers. And we'll only keep the lowercase letters here. All right, so we have two strings of the same length, one having all the uppercase letters, one having all the lowercase letters. Notice that lowercase a is in the same position in its string as an uppercase a is, so on and so forth. All right, so we're going to write a loop. I is 0, I is less than. It doesn't matter if you choose uppers.length or lowers.length because they're the same length. All right, so we're presuming that whoever calls this, which is going to be us, is going to pass in an uppercase letter here, and we want to get it to its lowercase equivalent. So we're going to say if uppers at bucket I is equal to the character that was passed in, then we want to return lowers at bucket I. The same location, but in the lowercase string. That'll convert the uppercase char into a lowercase char. You could also do ASCII math and things like that. There's lots of different ways to accomplish this, but this kind of fits the pattern of what we've been doing in terms of using the strength of strings to accomplish these things. Okay. So now we know how to convert an uppercase character to a lowercase character. All right. So we're going to go ahead and create now the so let's do string upper case to, actually this will be good, upper to lower. We'll talk about this more later on in the term, but notice I have two functions that have the same name, but they take a different number and or type of parameter. So both of these guys are called upper to lower, but one of them takes a string and we'll convert it to the entire string to lowercase. Where the other one is it takes a char and we'll just take that single char to lowercase. So again, kind of tools that we can work with here, but we'll see how this concept that I just explained here is called polymorphism. When you have two functions with the same name, but they take different inputs. Okay, so we'll go ahead and write this guy. So for this guy, we're going to have a string we're going to be building. Let's build it inside of a string called answer. We're going to go through every character in S. I is less than S dot length. I plus plus. Okay. And we want to now use some of our functions to ask a question. Now, presuming the value we're going to pass to this guy is going to be something that's already had all the non-letters removed, you can put error checking and things like that in there. One thing I want to go back and do here real quick is we have advertised that we're going to return a char here. We know because the way we're going to be using this function that we will get in that if statement at some point. Right? But what we probably would want to do here just for consistency is we would say not an upper case letter in the event that we're still alive down here. That means whoever called this passed it a bad value. And then maybe we'll return the char question mark, something like that. We don't expect to ever get to these lines. But for completeness, since we have advertised we're returning a char, we'll go ahead and put this in here as maybe a reminder if we happen to use our function incorrectly. All right, so back to upper to lower for strings. We're going to be building a new string, which has all the lowercase letters as is. And anytime we run into an uppercase letter, we're going to concatenate on the lowercase equivalent. So we already have the ability to ask if something is uppercase. So we're going to have a loop that goes through our entire string. We'll ask a question if S at bucket I, well, is uppercase of S at bucket I. So if it's true that the current character we're looking at is uppercase, we want to say answer is equal to answer concatenated with, we want the upper to lower of S at bucket I. So we'll take that uppercase letter that we just discovered. It is uppercase, therefore we want to convert it to lowercase before we concatenate it on. If it was not uppercase, we'll say answer is equal to answer concatenated with the char as is. It's already lowercase. In the end, we'll go ahead and return answer. All right. Now, if I were writing this not for a video that I'm trying to keep relatively efficient so you can kind of go through it on your own um, uh, for studying purposes. I would probably be testing each of these functions as we go. Some of them we've already written in previous assignments, but we'll see if I regret that decision or not. Um, but in any case, so this guy's going to take a string as a parameter, return a string that is that string with all the uppercase characters changed to lowercase characters. So we'll go through the whole string. Whenever we see an uppercase character, convert it to lowercase before we concatenate it on. Otherwise, if it's already lowercase, just keep it as lowercase and concatenate it on. So in the end, this guy will give us um, an all lowercase string. Okay, so now let's kind of put these together and then go from there. Really, at this point, we're just ready to start solving our anagram problem. All right, so let's go ahead and we'll have this guy return a Boolean. His anagram. We'll take in a string S1 and a string S2, so two strings. And what we want to do is we want to go ahead and convert these guys to the lowercase, their lowercase equivalents with all the extra stuff taken out. So calling all of our little functions on these guys. All right, so for starters, we're going to go ahead and we're going to change S1. So let's just go through a bunch of filters. We could put it in a new variable, but we can just overwrite S1 since we're not going to need the original. We want this modified version so that we can then go and determine if it's an anagram. So we're going to say S1 is equal to, let's go ahead and figure out which one to do first. So the first thing we're going to do is we're going to call remove non-letters from S1. Let's do the same thing to S2. Now, hopefully you're seeing the value, the power of us writing those little tiny functions that do something, because now we can just rely on them. So the very first thing we did is we overwrote S1 and S2 with the remove non-letters version of themselves. All right. Then we want to go ahead and get the upper to lower case version of it. So we'll say S1 is equal to upper to lower of S1. Keep in mind that this second S1 here is already been modified to have non-letters removed. We'll say S2 is equal to upper to lower of S2. All right. So when we get to this line right here, we'll say both S1 and S2 have all non-letters removed and are in all lower case. Okay, so that's the current situation. So now we have two strings that we can now go and look at to find out if these guys are anagrams. Okay, so to be an anagram, it means that the strings have the same letters in them, but not necessarily in the same order. So what we probably want to do is we probably want to go through, first of all, we can throw it out if they're not the same length, right? Presumably, I'm trying to think, the definition of an anagram, does it allow, I'm going to treat it as if a word has two A's in it, both of them would have to have two A's in it, even if it's out of order. I think that's accurate anyways, but so it's not just that they have the same letters, they have the same number of those letters, just they're not necessarily in the same order. So right off the bat, we could ask the question, if S1 and S2 are not the same length now, that means they're not anagrams. All right. So if S1 dot length is not equal to S2 dot length, return false. If they're not even the same length after we've done all this modifying to them, they're definitely not anagrams. All right. So else, they're potentially still anagrams. So what we're going to do is we're going to go ahead and we want to go through the each string and we want to count occurrences of each of the characters in that string. Well, I think that's something else we've also already written. So let's go up here and write another one. Int count occurrences. And this guy will take in a string and a character. I think this is from a couple of questions ago. And what it's going to do is it's going to return for us the number of times it found the character stored in C inside of the string S. All right, so we're going to have a loop. Print I is equal to 0, I is less than S dot length, I plus plus. We're going to need a variable to keep track of our count. And I like to put it like a space in there. It's not required. All right. And what we're going to do is we are going to go through and we're going to say if S at bucket I is equivalent to the character stored in C, then we'll say count plus plus. And then we will return the count. All right. So now we have the ability to call count occurrences. So now back down here, if we're in this else here, we know the strings are the same length, at the very least. So now what we want to do is we want to go through the strings. We know they're the same length, so it doesn't matter which string we operate off of for the length. So we'll say for int I is equal to 0, I is less than S1 dot length. You could say S2 dot length as well if you want, because we're only in this else if they're the same length. I plus plus. Then we're going to go ahead and get our count for the current letter. So we'll say int count per char S1. I'm getting a little verbose there, I guess. That's going to be count occurrences, passing at S1 and passing at S1 at bucket I. And then we're going to say int count per char S2. That's going to be count occurrences, passing at S2 and passing at S1 at bucket I. All right, so this part's a little bit tricky because what we're doing here is we're basically saying we are going to operate off of S1 as our source material. We're going to, as we walk through S1, we are looking for situations where the character we find in S1 occurs a different number of times in S2. So in order to do that, we need to find out how many times did it occur in S1, and then we're going to find out how many times did that same character occur in S2. That's why we're using S1, again, for the char we're passing in, and we're giving it S2 as our source. Go and look in S2 to find out how many times the character we're currently looking in S1 occurs. All right. So now those two guys contain the number of times that letter exists. Well, if it's a different number, if those aren't the same, these guys are not anagrams. So if count per char S1 is not equal to count per char S2, that means whatever letter we're currently looking at, it occurs a different number of times in the two strings. Therefore, not an anagram. Current character occurs a different number of times in the strings. So that's why it's false. Okay. Now, if we do that for every single character in S1, and we found for every one of those characters, they occur the exact same number of times in both strings. And we know that both strings have already had all the non-letters removed and have already had all of the letters converted to lowercase as necessary. So we know they both have the exact same case of letters in them. This is where we fail the anagram check in here. So if we are still alive after this for loop, that means we've jumped through every single hoop and determined that they do indeed have the same letters, potentially in a different order. Um, I guess the way we're currently writing this, it is possible they're in the same order. So we could, I'm trying to think, as an anagram, um, or two strings that are exactly the same are those anagrams. Even if they're in the same order, it's possible. I'm not sure the exact definition of anagram. If that is not allowed, it would just be a little if statement. Probably write another function just to compare two strings to each other, character by character. But let's just assume that if they happen to be in the same order, we're just going to call it an anagram. But this captures the idea of them having the same number of the letters. Okay, so if we're still alive after this for loop, we're going to return true. All right, that means it is a anagram. All right, so now we can go and test this guy. So let's go up here and we'll say bool answer is equal to is anagram. And let's give it HELLO. And let's give it ELLHO. So this should give us a true. That's a true. Got a 1. But now let's throw, let's put a couple more O's in there or something like that. Okay, that's false, not an anagram. Let's do another hello world. So these are the same length strings, but they're not anagrams. That's my false. And then we could always give it strings that are not the same length, so we're not getting very far into the logic. That's false. Okay, so I'd encourage you to go through this one step by step and try to mimic what I'm doing. Obviously, this was fairly complicated, but keep in mind that there is um, uh, I've said something in class that all hard programs are made up of a bunch of these easy parts. We've just written several little functions here, and each of these functions independently of each other are not that complex. Is anagram is probably the most complex, but we broke them down into little tiny pieces and we did not worry about the efficiency of them because computers are fast. All right. So I'll see you in the next video. I do recognize this one was probably a little tough, so I would not ask you this on an exam because of the time limit, not because it's too difficult. All right, I'll see you in the next video.